Introduction to Web Programming JavaScript Part 2. So we had a Part 1 and now we are going a bit deeper to JavaScript. So there are different ways to define a function. So first of all, we have met already this that we can create a function. Let's call it a sum. It takes two parameters, a and b, and then there is the function body inside the brackets. There is also another way to define function. We define a variable and we point a function to that variable. So then we can throw that function to other function, for example. It's just a variable. And then we have these anonymous functions. So here we set timeout and give it a function that it will call after the 2-second time. So there are 2000 milliseconds. And here we do not have any name for this function. We have just anonymous function, and the anonymous function itself will just print JS rules to the console. So that's anonymous function. And in JavaScript, it is quite common to pass function as a parameter to some other function, especially when we are dealing with React, which is not part of this course, but in real life you will definitely meet React when you are programming with JavaScript. And the thing is here that you need to have a way to pass a function, not just the return value of that function. That's why we are using a lot of anonymous functions, for example. And to that, ECMAScript 6 brought arrow functions to shorten the code, which is very good. We want to write short code and save our time. So we can shorten this anonymous function definition or the function definitions like this, that we have a sum function like in the upper part of the slide. But now we are just taking parameters a and b, and what we are doing, we are returning a plus b. This is all what we need when we are defining a function. This is of course very strange, so let's have an example on this. Okay, let's see some demonstration. Now we have just very empty web page. There is index.html which is empty, and basic.js which is empty. So let's add here our HTML part and then link those JavaScript parts like this, and the source is this JS class basic.js like this. And now one way mentioned was this, that this script is loaded at the same time as this HTML, and when this is here run, this part of the page does not exist yet. The most easiest way is to just write the word defer here. So now the JavaScript file is loaded at the same time as the HTML, but it's only started to run after this rest of the page is loaded. So it's one of the quickest way to get the things work as you probably want. Let's just add a button here, so call it a button. And now we have a web page that has a one button, and then we will need this console, of course, also. And let's go to the basic JS and write console log, am I working? Yeah, I am working. By the way, then if you have this live server installed, I have somewhere some kind of a live server, you can just press right mouse button and open with live server. This will open the web page in live server and it will refresh all the times you are doing some modification here and save the code, and then you don't need to install any hard heavy server things, but it has its own shortcomings too, so I'm not right now using that, but if you wish you can. But this is all we need in the HTML part. Now we are only focusing on the JavaScript part here. So it is working, it did write us that I'm working, okay. So then let's check how these functions are working in JavaScript. Let's create a very basic function called sum. It takes a parameter a and b, and it's only returning us the sum of these functions, sum of these variables a and b. Very simple function, and now we can log. So we are giving this sum two variables, two values, 5 and 3, and it's working. We can actually, this console is in that sense interactive, so we can write here sum 4 and 8, and it's returning us 12. We don't even need to use this console log here. We can just use it if we wish. Then let's create another function. Let sum2 equals function, and it takes parameters a and b. No, write that. And this will also return a plus b. So it is working very similarly than the first function. And if we are using that here, we are getting 8 and 8. So it is working in that sense. And the anonymous function, so let's set timeout. So this is a way to do something after some time has happened. So we need an anonymous function here, like this. And then we are doing something in this, we are calling this function, so this anonymous function, after some period of time. So 2000 milliseconds is fine, 2 seconds that is, and we can just log that 2 seconds have passed. Let's see. Now if we wait 2 seconds, it will print us. So 2 seconds have passed. So here we have this, let's say, very traditional old way to define function. So we have a function sum, okay. Then we define a second function that is in a variable called sum2. So we can drop this variable to anywhere if we wish. And then there is a way to have an anonymous function. So all the stuff is in here. But of course we can call here another function. We are actually calling this log function, but we could call, if we have this like this way, then let's call this sum2 function with some kind of a values like that. Now if we wait 2 seconds, it will log this, and then it's calling this sum function and print the results there, 28. So this is working quite well. We have now learned that there are plenty of these function keywords, but we can shorten this a lot. So let's define sum3, and it is a function. It takes 2 parameters, a and b, and then we are just returning a plus b. Very simple. So here are the parameters, and then this is the return value. There is a invisible return keyword, so this will be returned. Let's define another function called squared. That is a one variable only, x, and it's returned this x times x. Let's see if these are working. Sum 3, 4 and 9. and then we are calling this squared with a number of 9. Let's see. Y is not defined. Yeah, why there is a y? Who put it there? Yeah, 13. Yeah, that's working fine. And then 20 for 81. That is working also. So this is the very simplest way to have a function. And this arrow function is really saving time. You don't need to write the word function. You don't even need to have these curly brackets there. But of course we can also have a larger function. And then we can have the several parameters like A, B, and C. And we are doing a lot of them, so then we can do things and return something A plus B divided by C, something like this. You can define it with this curly brackets also. And classes in JavaScript. So as mentioned already, JavaScript is prototype based. It is not class based. It's prototype based, and we have several ways to create an object or a class. Let's see. So first, this is how we create an object. So this is not a class. We just create an object by using those curly brackets. And in this object we have a member variable data, we have a member variable index, and then we have a function get serializable, which is returning this data and this index. So this is object. So you have created one object and there is no class to create a second object. Then you can create a class using the keyword function. So here we have a class called car, and it has a member variables model, color, get info. We create a method called get car info, which is returning this color, this model, and car. That's string. And that is just a general method you can use with the object then, but there is also a way to input that method inside the car prototype. So then it would be car prototype get info, and there would be this function. And we can then create a new car with the new keyword. So there is no class keyword, there is a function keyword to define class. So in JavaScript, so many things are functions. And you can define a class like this. So we have this function get info inside this car. But the problem here is that if you are defining the function like this, then it's every time you create a car object, you are getting a new function, which is bad in that sense that it takes resources. It's slower to create that kind of a method. So this prototype get info thing is better, it is faster. But this is not all. ECMAScript 6 in 2015 brought the keyword class. Well, it's mainly syntactic sugar, but makes class definitions much prettier, and there are some things that are not just syntactic sugar, but it's a bit irrelevant in this course. So what we can do? In JavaScript, yeah, we write more functions and less classes, for example, if we compare it to Java, but this class keyword lets us define classes a bit similar way than in Java, for example. So here we are defining a class called car. It has a constructor, which is invoking this setter method. So we have a set model and get model. So there is one member variable model, and then we have a way to return the model and set the model. And in the set part, we just check that if the name is too short, then we are not setting the value. And once again, we can create a new object out of this class. Teslas here and there. What else? Event listeners. So what we already learned that the interaction in the web page happens through event listeners mostly. So we can add some kind of an event listener to some element. So there is an event and there is a function call and there can be some options not relevant to this course. So event, for example, click or double click, and then a function that we are calling. So you can give the element itself as a parameter to the function, but note that you cannot give the function directly, but as an anonymous function that calls the real function. Otherwise, only return value of the function would be given. So this kind of a clause won't work. So we would have here a function called func, and it has a parameter element, but this doesn't work because the func function is then called directly, which is not what we want. But we need to have some kind of a anonymous function there, which is then defining this function call. And this second version works. Let's have an example on this one. Okay, let's continue. We can just, let them be here. Let's continue. So we have this one button here, but nothing happens when we are pressing it. So let's do something with that button. So first we need to get that button. We can get it with through this document get element by ID, and its ID was button btn. Now we have the button, and now if we check, no errors, this is working because we have this defer keyword here. So the JavaScript is being run just after the whole HTML page has been loaded. So let's add an event listener to this button, click, and what should we do? We can use now the arrow function here and do something. For example, we can log and call, let's call some function we have defined, this sum3, for example, with numbers like 63 and 129. Now if we press, it will give us the sum, and then this is still going strong here. This will work because we have created an anonymous function here, and this function is here. When you click it, then this function will be called. But let's define another function called just function called hello. It will take no parameters, and it will just log hello, just like Adele is doing. And now we can get rid of this. Now we can just put the hello here. So we have an event listener, and we are putting a hello here as a callback. This function will be called when this click event happens. And now there is only the function name here. So will this work? Let's see. Yeah, it did say hello. It is working. But if we wanted to give a parameter here, x, and then we would have a hello x. What would happen now if we would give here hello Adele? Let's see. No, nothing is happening. But here is a hello Adele, but nothing is happening because this function is already called immediately, and the return value is then set here when you are pressing a click. So it won't work as we want it to be. But if we would use this arrow function, then it will work. Now every time you press me, then there will be a printout of hello Adele. So now it is working. So this is why we are using anonymous functions into things like adding event listener. Next, query selector and query selector all. So we already get used to this get element by ID, which is fine when we want to get a single element by its ID. And query selector lets you build more complicated queries. It uses the same syntax that is in cascading style sheets, so CSS. We will cover that later, but this query selector will return the first found element, just like the get element by ID. And then we have query selector all that will return all the found elements, which is very useful. We can, for example, select all the elements that have a class called green in their definitions. And then we can do something about those elements if we want. Or we can use this query selector and select an element with the ID of title. Then it works pretty much the same than this get element by ID. And yeah, the syntax will be more clear when we are learning CSS in the future videos. Then there are several nice JavaScript tricks with these newer features of JavaScript. For example, we have a map method, and it creates a new array and populates it with the results of original array with modification. And it's in a way it's similar than for each, but this will return something to you, and then you can work with the return value. Then we have this usage of logical AND. So when we are using two ampersands, and there exist several useful use cases for this, we will cover them later. Then there is a spread and rest syntax, 3 dots. This lets developer to explode or implode some iterable element. So then there is this optional chaining, $dot. It is very useful, it saves your time, especially when you are going through some deep chain of connected objects. So you have an object inside your object and you want to dive in to check if there is this specific attribute. Then we have this nullish coalescing operator, $. It returns the right hand operand if the left one is null or undefined. So this is different from this OR operator that will return right even if the left is empty, like a empty string or 0, but this nullish operator does not count these two cases. Let's have an example on this too. So then we have a lot of different things here. So let's first define few variables. First, actually arrays. Let's have letters A, B, and C, and D. And then let's have also numbers. So a second array, 1, 2, 3, and 4. Like this. So now we have two arrays. So what could we do? So let's get square. Squared. So we have already this kind of a function. Let's define squared numbers variable. And this is something we want to get these numbers, all these numbers to square. So we could have a for each loop where we are using these as elements in that for each loop and doing this squared call to them. Or we can just have the numbers map, and here we are defining that we are taking one item at a time, and what we are doing to those items, we are just squaring them. So let's log these squared numbers. So now we got all the numbers squared in an array. So it's taking the array squaring all the numbers and building another array. So if we are not using this return value, then we could easily use a for each loop. It would be definitely the better way to go just with the for each. But if we wanted to pass these numbers to some other function or do with some other magic to those numbers, then that would be fine. But if we want to modify each element, then this map is quite good. Then the second thing, let's define an age variable, and age is 18, and then define also another variable called adult age. And this adult age is age greater than or equivalent to 18, then and age. So what does this thing do? Now we are using this and logical and operator here. So let's just log the adult age. Let's see, now it is printing 18. So the adult age is 18, and if this is like a, well, no one is that old, but 67 please. And it's printing 67. But if we are underage, we are only 17, then it's printing false. So you will see this kind of a code somewhere in the internet. If something is okay, then we are using this variable, but if something is not that, then we are getting this part of the code. Now we are just doing some checking here, but we could have a if name, then we would have a age, or otherwise we would have a name, which is very bad example, but it's an example. Then let's continue and let's build a function that is taking numbers. So take numbers, and it will take several numbers, x, y, z, and w, like this, and it will return x times y times z times w. But what if we wanted to use these numbers in array here? How could we do that? Let's see. So of course we can call this take numbers and give it a parameter like numbers. Now this is an array. Let's see what will happen. Not a number. Yeah, definitely. This is an array, it's not a number. So we can of course define that we are giving a first and then the second. But no, this is way too long. We wanted to give all the numbers individually, like this. And now it is giving us 24. So 1 times 2 times 3 times 4 is 24. So it is working. Isn't this annoying that it is giving us this? 2 seconds have passed. Yeah, very annoying. But now we are giving all the numbers from the array as individual numbers. We are breaking it down, and this function will work. This will also work the other way around. So let's build another function called print everything, and it will take some kind of some stuff. It will join all the stuff that is getting to one array. So then we have a array here. We can just first log that printing everything, and then we have this stuff variable, and we can of course use for each to go it through. And once again, arrow functions here. And what we want to do is just to console log this x. and we would like to give something to this print everything. We are giving it a, let's give it a string, then some numbers, then again string, then we can give it that object like this, and of course we can give it an array 3, 4, 5, 7, and we can give it a variable. We have these letters. So we are giving this function quite a lot of different stuff, and it's only taking inside one variable, and it will join all this stuff in the one array. Let's see what will happen. Letter is not defined. Okay, I'm using letter here. Maybe I should have used letters. Did I have letters? No, no letter, no. Yeah. Okay, now it's printing everything. Like here, at the first it will print string, then 577 SSD, then there is an object. It will see that it's an object. Then there is an array, manually defined, and then there is this variable letters, which is also array. So yeah, this is quite nice also. What else? Let's first define a data item. I will just copy paste this data item here. Like this, we have a data which has attribute name and age, and then there is address, and inside that this address is a object, so this data is also object. So there is a street attribute street, and code that are strings, and then there is an object called city, and it has name and status. So Lahti is definitely alive. Finnish version of Chicago. Yeah. Okay. How? This is deep. There is object inside object of the object. So we can try to log something out of this. So we have the data variable. It has a address member variable, which has a city member variable, which has a name member variable. Let's log it. We should get Lahti here. Yeah, and that we did. So everything is working quite well, but what if our data structure is malformed, or it is missing something, or we want to know that if there is something like that. So for example, if we are checking if the address, now there is no address, and we are getting an error. Cannot read properties of undefined. So there is no something like address. Of course, we could go build some kind of if statement that if data address is if data exists and data address exists and data address city exists, then we could log this data address city name, and otherwise we could just log that failed, and now this doesn't work. So let's see. Now it is giving us failed. So the program is still functioning. It will not crash as this would crash. But this is kind of hard when you want to check all the variables if there are those such things. So let's copy paste this and try it again. So now this won't work. Yeah, it will crash. But if we are just asking if this data is there, then if there is address, if inside the address there is city, then just get the name. And now it's working, and now it's getting us undefined because this address does not exist. If we now fix the error, then it's giving us Lahti and Lahti. So both of these are working, but guess what? This is one line, and this is like 6 lines and a lot of more characters than this one. This is way much shorter. And then the last thing, let's get a few variables here. So let's give a equals 0, let b equals null, and c equals text. So 3 variables, and then we are just checking that. Let's print a and c. So if this, yeah, well, we can do that. We can do a lot of things here. Like this one. Let's see what will happen. So first we got 0, then we got text, and then we got 0. So does this a exist? If it does, then c. So it didn't, it was a 0. Here we have or, so we get text. And here we are asking that if this a exists, then this c. Let's get these all here and change the a from a to b. And let's run it again. So in this first case, we are getting, yeah, there is a null, we are getting that, yeah, fine. In the second case, null or text. So the difference here is that this will produce us 0 and this will produce us text, whereas this will produce us text and this will produce us text. So these are almost the same operators, but they will happen differently if there is a 0. This is a nullish operator. It will react only to null or undefined. So you will also meet these when you are learning and reading JavaScript from the internet. So now you know that these concepts exist. So as a conclusion, JavaScript is a very unique language. It has features that do not exist in Java or PHP or Python or C, especially not in C. And it is evolving all the time. So these new features are popping in basically almost every year, and then you can use them once you have learned them. And it really takes time to understand how things are done in JavaScript because they are so different from, for example, Java. But in the end, the development with it is very fast. So these features we were seeing, they shorten your code, they let you iterate fast different data structures and let you do things quickly.